explore one-to-one functions. So here we have two relations, and let's first ask, are these relations functions? Let's take the top one. We see that each element of the domain, each student, has exactly one arrow emanating from his or her name. So this is a function here. And for the relation on the bottom, again, each student has exactly one arrow emanating from his or her name. Now we want to ask the question, are these functions one-to-one functions? So here's the definition of a one-to-one function. One-to-one means that different inputs have different outputs. So if f is our function, f is one-to-one if for any two different inputs, x1 and x2, we have f of x1 not equal to f of x2. So this top relation up here, this top function, is not a one-to-one function. Because the two inputs, John and Michael, have the same output, history. Down here on the bottom, different inputs do have different outputs. How about f here? Is f one-to-one? Can we find two different inputs that have the same output? Let's take a look at the formula, x squared. So if I take a number and it's negative, I will always get the same output. For example, f of negative 2 is 4, and so is How about this function? Is f one-to-one? Well, for it not to be one-to-one means that we can find two different inputs with the same output. Let's take a look at the formula, x squared. We see that a number and its negative will always have the same square. So, for example, f of 2 and f of minus 2 have the same output, which here is 4. So f is not one-to-one. I found a pair of distinct inputs with the same output. Now this is reflected in the graph in the following way. If I were to graph y equals f of x, the fact that 4 is an output associated to multiple inputs means that the horizontal line y equals 4 intersects the graph in more than one point. So we have a test for a function being 1 to 1 based upon its graph. F is 1 to 1 if the graph passes the horizontal line test. Which means that every horizontal line intersects in at most one point. Let's see an example of a function whose graph does pass the horizontal line test. If we graph y equals f of x, we see that the graph does pass the horizontal line test. Every horizontal line either sects the graph in exactly one point or 0 points. Either way, it's at most 1 point. So we know right away that f is 1 to 1.